Topic 3-3, finding missing factors and greatest common factor. A lot of times you'll see your teacher write GCF. Factor out the GCF. So what you're looking for are missing numbers, or, well, something that can be factored out completely. This is referenced in our Holt textbook on Chapter 8, Section 1, page 524, and Chapter 8, Section 2, starting on page 531. Okay, let's look at the first couple of ones here. You've got a pretty large number here, but they're saying what would be the missing number if this was 6a squared, m to the 7th, times what would give me this. So what you're thinking is, what if I put this down here at 6a squared m to the 7, this same thing, and I divided it by that, I would end up with this answer, because you know that when you multiply an unknown times a known, you'll get an answer, and therefore dividing this one by that number would give you the unknown that we're looking for. So 24 divided by 6 is 4. Remember, when you have same bases, your variables are the same, then you subtract in division. So this, having 5 A's and 2 A's, subtract would give you 3. 9 M's and 7 M's, subtract, and it will give you 2. So your missing number would be 4a to the 3rd m to the 2. Here you're dividing by a negative, so you end up with a negative. Always remember, you don't have to put a 1. So when you're doing the subtraction, this one would be 1. This would be 5. And therefore that's your missing number. This one's a negative. Make sure you remember it's a negative number. Okay, look at number 3. If you're taking all of this number, everything on this one, you're looking at something that's a greatest common factor, because you've got all of that, but we have to make sure on this side of the equal sign we multiply first. So this times this gives us negative 10. 1a and 3a's give you, 2a's give you 3a's. 1b and 3b's give you 4b's. So it's actually this number, not just these individually, that it will be divided by your product over here. So again, make sure you keep a negative. That 30 divided by a negative 10 is a negative 3. Subtract and get 3. Subtract and get 1. And again, you can put the 1, but it's not often. You won't, well, you'll probably never see a 1 given to you. So finding greatest common factors. These have been done visually, showing that if you have 5 x's and 3 x's, what's common between both can be circled. So it's always going to be, when you have like variables, the lowest variable that you have. And on this one, I do have x's in both, I do have y's in both, so the lowest number of y's is 2, and the lowest number of x's is also 2. Looking at it visually can also help you circle some common factors in both terms, because they've separated these by an and sign. Alright, let's scoot this up a little bit. For 16 and 20, what goes into both of them is a 4. So 4 times 4 is 16, and 4 times 5 is 20. So you can look at that, and also remember I said it's always going to be of your like variable, the lowest number that you have, which is m to the 2. Now on this one, you have a common factor of 8, and c is in both, but not d and e, so the only thing that's going to be common as far as variables go is c to the 3. You don't have any d's in the second term, and you don't have any e's in the first term. So if it helps to draw the visual of everything you have in the like terms, then go ahead and do so. But I'm going to move on. If you want to pause it to finish copying that, you can. Okay, let's look at number 8. On this one, notice the visual. We wrote out all of those visually of what everything was, and then just started circling common things. If you can look at this and that out of 12, 14, and 15, my factors do not add, or there's nothing common in any of my whole numbers here. So notice your greatest common factor has nothing common amongst 12, 14, and 15. But as far as the y's, what's your lowest number of, well, let's start with x's. The lowest number of x's is an x to a 2. This one has x3 and this has x5, but your greatest common is 2 of them. The lowest exponent on our y's that are common in each term is a 2. Therefore, it's y to the 2. The lowest number of terms on my z is just 1z. So it just would be a z. So if it helps, write it all out. But if that's too much, then you can just look at it individually and just take out however many, the lowest power of exponents that you have. So write the equation of a line that describes the slope in y-intercept form. Notice how on each one of these we're actually kind of going back into review. Very highly tested over linear equations. So if you've been given intercepts of lines and asked to write the equation, you first can find the slope. If you've been given, well, you haven't been given 2 points, but knowing something about intercepts, you know that on an x-intercept, if it's at -12, there is a 0 for my y. So if you need to put that, that's your y, this is your x. If you want to intercept a y value at 0, 6, this is my x and this is my y. If you need to see this visually, let me show it to you. This can be done with this right here. If I have a -12, actually it only goes to 10, so we'll just have to put it here. This is a grid of 10. And then my y-intercept is at 6. 1, 2, 3, 4, 5, 6. This is actually the line that it would create. So if you're trying to come up with the equation in slope-intercept form, if you want to write that down, it's y equals mx plus b. Well, notice, remember, you'll often see me do this with the graph. Y equals mx plus b, this is my b. The b is always your y-intercept. So the intercept was at a +6, and the slope movement is down a -1 over a -2, down a -1 over a -2, down a negative, and keep going all the way till you get to that intercept. You can also think of it as a +1 over a +2, up 1 over +2. That's where, I'll go ahead and leave this, where to put it. Let's see, I'll just put it right there. I'll leave that on here, but that's why this is the equation. So you can do it through finding your slope formula, which was done here, and then put in for intercepts if you knew what it was. But graphing it can also be one of the easiest ways to actually figure this one out. Okay, look at number 10. The line is perpendicular. Well, we have to remember that perpendicular, we're looking for opposite reciprocal slopes. Reciprocal, just a large word for the word flip. So you're going to flip the slope. So you first want to figure out what this slope of this line is. So first of all, finding the slope is what they did over here. They copied the problem down again, rearranged it, always moving the x to the other side, which made it negative. Dividing out a -3 gives you a positive y. Cleaning this up a little bit gives us this equation. The opposite, or you could think of negative reciprocal. Sometimes I use the word opposite. You take the opposite reciprocal, so 1/3 x flipped. I'm going to see this more. Then that becomes 3/1. Opposite means making it negative. So this is now our m, which is often not put over 1, but when you're graphing it, you want to make sure you would walk down a -1, 2, 3, and then over a +1. 1, 2, 3 over a +1 to get your line. You're always making the movement of rise over run for slope, but not often does your slope come in fraction form. So you have to be careful with that. But you also want this to go through this point. So in this problem, you're not using the slope-intercept form, you're using the point slope form. So look at your formula chart for point slope. So when you've been given a point and a slope, you would have to fill in this point. So I'm going to draw some arrows. This 3, it was put in right here, and this negative 11 became a positive 11 because your point slope formula is y minus the number equal to the slope times x minus the x number. So this is your formula that you're using. Working through the algebra distribution, you distribute it to get this, and then we had to subtract 11 on both sides. That's why this became negative 2. Pause this, go over this with me if you need to again, but you've been given a point and a slope, so by doing so you can put it into y-intercept form. And that concludes 3-3.